This is the Sun, the star in the center of our solar system and star which supports life on Earth. It has some black dots on it. Those dots are called sunspots, which are normally colder than the rest of the surface of the Sun. The Sun is also the largest and most massive object in the solar system that accounts for about 99% of the mass of the solar system. Because the Sun is the most massive object in the solar system, it captures planets, asteroids, comets etc. and sometimes even directs their orbits. The Sun has very strong gravity which stretches almost all the way to the next solar system or star system. The Sun is a type of star called a yellow dwarf, because it is quite small compared to most stars and it looks like it is yellow in color, so it is called a yellow dwarf. Without the Sun, life on Earth wouldn't exist, as we are in the Goldilocks zone, which is not too hot nor too cold. The Earth is not cold because of the existence of the Sun, and the distance between the Sun and the Earth makes it average temperature. In about 5 billion years the Sun will become a red giant and swallow all the inner planets including the Earth, mainly because the Sun will lose its fuel, hydrogen, helium, and then collapses on itself and then suddenly starts to grow larger and rapidly into a red giant. After some time the Sun will collapse into itself again and turn into a white dwarf. The Sun doesn't explode into a supernova because it needs to be at least 10 times more massive than how it currently is. The Sun has some dark spots called sunspots which are created by strong magnetic field lines on the Sun. The sunspots are cooler than the rest of the Sun. The Sun is made of many layers like the corona: inner core, outer core, radioactive zone, convection zone, subsurface flows, photosphere and the chromosphere. This picture here has some detail. The Sun is made up of hydrogen, helium and heavier elements. Hydrogen converts into helium after two hydrogen molecules collide. This is called nuclear fusion. Nuclear fusion happens in the core and it is like a source of energy for the Sun. After hydrogen converts into helium, then helium converts into heavier elements like lithium, beryllium, boron, carbon, nitrogen, oxygen etc. That matters on how many molecules collide together. The Sun needs nuclear fusion to keep alive as gravity presses on the Sun, while nuclear fusion creates some energy inside the Sun that counters the gravity and keeps the Sun alive and in its current size. Also, nuclear fusion is thought to happen in the cores of other stars in the universe. Also, if you were wondering, nuclear fusion doesn't happen naturally on Earth, at least according to what we humans know. The Sun is made up of many different layers. They are the chromosphere, photosphere, convection zone, radioactive zone and inner and outer cores. The corona shown in the diagram isn't really a part of the Sun, but it is the atmosphere of the Sun. The Sun has a very large and complex magnetic field which is about 1 Gauss. The magnetic field stretches nearly all the way to the Oort cloud. Because it stretches that far, it has a very large influence on the solar system. Also, the magnetic field protects the Earth from things like gamma rays which can scar life on Earth. One thing that is unique about the Sun is that it can generate more than one magnetic field, as some random parts of the Sun can generate their own magnetic field. So the Sun has thousands of magnetic field. Our star, the Sun, formed about 5 billion years ago in the Orion spur, the Milky Way, most likely after the leftover gas from a supernova. Then some remaining gas got pushed away by the Sun to form planets, asteroids, dwarf planets etc. The Sun is made up of many gases, but mostly hydrogen and helium, while other gases are there in minuscule amounts. Because of the extreme temperature of the Sun, all these gases are in a liquid-like substance called plasma, which technically occurs on Earth in the form of fire. All the plasma on the Sun rotates continually, but to finish the rotation is in different times. The plasma on the north and south of the Sun takes 30 days to finish a complete rotation, while the plasma in the center takes 20 to 25 days to rotate around the Sun, and all the difference between the rotation of the plasma creates the different magnetic fields. Even though we cannot see the magnetic field of the Earth from the Sun, we can see and notice its effects. One of them is sunspots, which I mentioned before. In an area where a sunspot normally happens, there is a strong magnetic field which makes the sunspots. Also, the magnetic field of the Sun protects us from cosmic radiation from outer space and possibly even gamma rays from supernovas which exploded recently.